For us to find the volume of the region under the surface z equals xy squared, and above the area in the xy plane bounded by x equals y squared and x plus y equals 6. So first looking at this graph in the xy plane, this curve is x equals y squared, and this line is x plus y equals 6. So the bounded area we're concerned about is this area here in the xy plane, so we're looking for the volume below the surface above this area here. Let's look at this at 3 dimensions before we set this up. This graph's a little bit busy, but the xy plane is graphed in yellow, the surface z equals xy squared is graphed in blue. If you look down on the xy plane, the bounded area we're concerned about is this area here, so we're looking for the volume below the blue surface above the xy plane over this area, which we can tell would be the volume in this region here, as well as a small region here on the left. So we'll find this volume using a double integral, where the integrand function is xy squared. Now we need to decide the order of integration. Looking at the area here, it's going to be easier to integrate with respect to x first and then y, because notice horizontally, this area is bounded by the curve to the left and the line to the right. So we'll integrate with respect to x first, and then y. If we did integrate with respect to y first, we'd have to have 2 separate double integrals, because notice how the area from 0 to 4 is bounded by this bottom curve and top curve, and then from 4 to 9, the area is bounded by the line and again the curve. So it's going to be easier to integrate in this order. Integrating with respect to x first, notice how the area is bounded by the curve to the left and the line to the right. And because the curve is given by x equals y squared is going to be the lower limit of integration in terms of x. And then for the upper limit of integration, we need to solve this equation here for x. Notice solving for x, we would have x equals 6 minus y, which is the upper limit of integration for x. Now for the limits of integration for y, notice how this point is the lowest point with a y-coordinate of -3. This point is the highest point with a y-coordinate of +2. And therefore for y, we integrate from -3 to +2. And now we integrate with respect to x, treating y as a constant. So the antiderivative would be x squared divided by 2 times y squared, or 1/2 x squared y squared. Remember, these are limits of integration for x, so we substitute these expressions for x and then find the difference. So when x equals 6 minus y, we'd have 1/2 times the quantity 6 minus y squared times y squared, minus, when x is equal to y squared, we'd have 1/2 times y squared squared times y squared. Now let's simplify. Let's go ahead and factor out the 1/2. So we'd have 1/2 times integral from -3 to 2 of the quantity 6 minus y squared would be 36 minus 12y plus y squared. We still have times y squared. And then minus, we'd have y squared squared is y to the 4th times y squared, that'd be y to the 6th. Next we'll go and distribute and then combine like terms. And let's do this on the next slide. So distributing, we'd have 36y squared minus 12y to the 3rd plus y to the 4th, and then we have minus y to the 6th. So we don't have any like terms, so now we can go and integrate with respect to y. So we'd have 36 times y to the 3rd divided by 3 minus 12 times y to the 4th divided by 4 plus y to the 5th divided by 5 minus y to the 7th divided by 7. Let's go and simplify this before we perform substitution. So we'd have 1/2 times the quantity. Here we'll have 12 y to the 3rd This would be minus 3 y to the fourth plus, let's write this as 1/5 y to the fifth minus 1/7 y to the seventh. So when y is equal to 2, we have 12 times 2 to the third minus 3 times 2 to the fourth plus 1/5 times 2 to the fifth minus 1/7 times 2 to the seventh. And when y is equal to negative 3, we have 12 times negative 3 to the third minus 3 times negative 3 to the fourth plus 1/5 times negative 3 to the fifth minus 1/7 times negative 3 to the seventh. And to save some time, I've already determined these values. This comes out to 1/2 times the quantity. This simplifies to 1,264 35ths. And then we have minus, this comes out to negative 10,611 35ths. And then 1/2 times all of this comes out to 2,375 14ths, which is a decimal, is approximately 169.6429. And again, this does give us the volume bounded by the surface in the xy plane over the given bounded area, which is this volume here as well as the volume over here on the left. I hope you found this helpful.